So today I'm going to demonstrate how we can generate a sinusoidal function and cosine function by adding different infinitive terms. So I started with the function f of x equal to x. So x is this is a line that passes through origin 0. Now I am going to plot x cubed by 6 factorial. So this is x cubed by 6 factorial. This is minus x cubed by 6 factorial. This is x, f of x equal to x. Then I am going to plot x power 5 by 5 factorial. And this is a function. So we can represent the function in terms of x. This is x axis, and this is y axis. So this we can represent as x power 5 divided by 5 factorial. Now I am going to add one more function, x power 7 divided by 7 factorial. So here we can see that how the function is varying all across of this x. So this is x7 by 7 factorial. This is minus x7 by. Now I am going to add one more function, that is x power 9 by 9 factorial. So this is x power 9 by 9 factorial. So here we can see that 1, 2, 3, 4, 5 different functions. One is x, it's a straight line, and that is minus x cubed by 6 factorial. This g represent minus x cubed by 6 factorial, and this one represent x power 5 divided by 5 factorial, and this function. And next function is x power 7 divided by 7 factorial, and the final one is x power 9 divided by 9 factorial. Now I am going to add all these functions together. Let's see. Yes. And here you can see that by adding all these functions, this one, and disabling all other functions now. Yes, see this one. So finally adding x power 5 by 5 factorial minus x cubed by 6 factorial minus x power 7 by 7 factorial x power 9 by 9 factorial, we can produce a sine wave. See, this is a sine wave. This is the sine wave when x equal to 0, the sine is 0. So when x equal to 180, so sine is 0. So what is 180? This point is exactly 3.14. This is the pi. So sine pi equal to 0. So what is this point? This point is sine 0 equal to 0. What is this point? This is pi by 2. So 3.14 by 2. So what is this? 1. So this implies that by adding all these different functions, so what are the functions? So first we started with this straight line f of x, and next we minus x cubed by 6. This is minus x cubed by 6, and next is x power by 5 factorial. Next is x power 7 by 7 factorial, and the last one x power 9 by 9 factorial. By adding all these functions, we finally generated a perfect sinusoidal function. Its maximum amplitude is 1, and it exactly crosses the x-axis at 0 and 3.14, and its peak is at pi by 2, 3.14 by 2. So this is what Taylor says. Any function, so this is the sinusoidal function, any function can be represented as sum of infinite terms. Here I generated only one cycle, so here you can see that one half minus half cycle and plus half cycle. So I just generated one full cycle by adding all this, the 5 different terms. That is all in terms of x. Now I am going to use the same technique that is explained by the Taylors, adding infinity to series of different terms to generate a cosine function. So just remember that cosine function, its value is 1 when x equal to 0, and its value is different from the sine functions. So just I'm starting with the parabolic functions. Here we can see that a parabolic function, this is a parabolic function, so x squared by 2 factorial, so it's in a different direction, so it is so minus x squared by 2 factorial. So now I am going to plot an x power 4 functions, and its function can be represented x power 4 by 4 factorials. And similarly, I'm going to plot minus x cubed by 6 factorials. So this is minus x cubed by minus x power 6 by 6 factors. So all are the power of x in terms of 2, the 2, 4 and 6. The next term is x power 8. So x power 8 divided by 8 factorials. So this function is x power 8 divided by 8 factorials. So we can observe that as the power of x increases, the curve is flattened, and it is just exactly running the parallel to the x-axis. And I'm going to plot one more function, that is x power 10 divided by 10 factorial. So this function is x power 10 divided by 10 factorial. So as the curve is oriented towards the minus x-axis, this is minus x power 10 divided by 10 factorial. Now I am going to add all these functions together and see that what will happen. Yes, I produced another function. By looking at a very closely observing at the function, we can see that the function is, its value is maximum when x equal to 0. When x equal to 0, that f of x is 1, and f equal to this, what is this point? This point is very close to 3.14 by 2, that is pi by 2. When x equal to pi by 2, this function equal to 0. So which function will produce the maximum value when x equal to 1 and the 0 when it crosses the x-axis at pi by 2? That function is the cos function. So by adding all these terms of different powers, x square in power in terms of the multiple of 2, x square, x power 4, x power 6, x power 8, x power 10, I finally produced a cos functions. See, now disable all the functions, just only sine functions. See, here you can see that this is a perfect cos functions. The cos, its value is 1 when x equal to 0, and its value is 0 when x equal to pi by 2, that is 3.14 by 2. So this is exactly same as the way we have seen before, where the powers of x are odd numbers, but here the power of x are even numbers. So this is what the Taylor said is any function in the universe can be represented as sum of infinite terms. But here in the infinite terms functions, here we can see only the function with the power a multiple of 2, but whereas in the previous cases where the power is in the multiple of odd numbers. So by adding the x terms of power even numbers, we can produce the cos functions, and by adding an infinity terms of x functions of different power, the power are in multiple of odd numbers, we can produce sine functions. So finally what Taylor said is exactly right. His theorem is proved here. Please subscribe this channel and keep watching all these videos coming up in the video tutorials. There are many others is coming. Please subscribe and start watching, learn, and be a pro in maths.